I want to look at just a sketch of where the law of sines comes from. This is not a complete proof. We're going to look at the case where all three of the angles in our triangle are acute angles, and of course we know that we can have triangles with an obtuse angle as well. And so I won't cover that case. The proof is similar. There's a little bit of bookkeeping you have to do. You have to use a trig identity, but it's very similar to the ideas we're going to see here. So here's the key idea. You simply drop a perpendicular from one of these angles. And of course, I want this to be a right angle off of the base B. I'm going to delete that just for clarity's sake. And I'm going to call that length H. And I've essentially created two smaller right triangles living inside my large triangle. And now I can talk about the sine of the angle A. And of course, I can view the angle A as an angle in the big triangle, or an angle in the little triangle. And the little triangle is the key because it's a right triangle, so I can use SOHCAHTOA. I can say, well, opposite is H over hypotenuse is C, and so I can solve for H, and I get H is C times the sine of angle A. Similarly, I can have a look at this little triangle, and I can talk about angle C. I can compute the sine of angle C, viewing C as an angle in the little triangle, and I get opposite, which is H over the hypotenuse, which is A, and so I get H equals A times the sine of C. And now we realize this is the same H, and so these two things have to be the same. And so I can equate C times the sine of A equals A times the sine of C, and I bet you can see what to do next. I can divide the C over, and I can divide the little a over, and of course I end up with what we know, and that is the sine of angle A over little a is the sine of angle C over little c. Well, that's one pair. There's another, right? This is supposed to equal, this whole thing is supposed to equal the sine of angle B over little b, and so where does that come from? And the idea is you simply drop a different perpendicular. And so we will drop one of those. Let me see here. Let's see if we can erase this. Oops, let's put it on hold. Let's see if we can erase that guy, and we'll switch to red. And so I've got choices. I dropped one off of the base B. If I wanted, we could drop one off of A here, and I want to just form it where, again, I get a right triangle. And this is where some of the other pictures get tricky, because sometimes when you drop it, you actually have to go outside the triangle and extend, but still the same ideas. So I do that. I'm going to call this H. This is not the same H. It may not be the same height. We'll call it H prime, because the point, I don't really care what H is. I'm using it to get to the other parts here. And now I can look at those smaller triangles, and I can write down that the sine of B is opposite over hypotenuse, so that's going to be H prime over C. And I can talk about the sine of C is, of course, again, opposite over hypotenuse here. That's going to be H prime over B. And you can play the same game here. You can see how this goes. You solve for H prime, and you can equate, and you'll end up with the sine of B over little b is the sine of C over little c. And when you combine these two, you're back to the result that we proved in class. So that's how you prove the law of sines, at least in this case. And like I said, the other versions we can extend to easily enough.